بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 into their 6th online lesson. And in this lesson, we will be talking about some word problems of counting principle, permutations, and combinations as well. So in this lesson, we're going to collect as many word problems as we can from the 3 lessons. We will see the differences between questions in which we use permutations and questions in which we use combinations, and also questions in which we use the counting principle. Before we start, we want to highlight some key differences between using permutation and combination. So I want you always to put in mind the following. In permutation, what we care about, or what we do actually, is we have a set of numbers or a set of elements, and in permutation, what we care about is selection. So we usually want to select a certain number of elements from from a larger set, and after we select, we care about arrangement. So in permutation, we care about selection and then arrangement, both of them. However, in combination, all what we care about is selection only. I have explained this before in the first class of combinations. So we said in combinations, all what we care about is selection only, and we don't care about the arrangement of the elements after we select them. So this is the number of the ways in which we can select R elements out of N elements, and this is the number of the ways in which we can select R elements out of N elements and then arrange those elements, arrange the elements that we have selected. Let's see this now today in some word problems and see if we can figure out the differences between the 2 scenarios. So today I have prepared for you some word problems. Actually, there are about 30 word problems. We will try to go through most of them. I'll leave some of them as homework for you for practice. Please feel free to send me any queries, any questions, any things that you do not understand. Send them to me via WhatsApp, and I'll make sure that I'll have them solved for you. So let's see. Let's start. Bismillah ar-Rahman ar-Rahim. Let's see these questions. So, hope this is clear. Okay. So, the first question. The first question says the following. In a library, a shelf holds 7 Arabic books, 5 English books, and 4 French books. In how many ways can an individual choose 3 books, such that the first is written in Arabic, the second is in English, and the third is in French? So, this is a counting principle problem. Always think of your problems as if they're counting principle problems. This is the first thing that you should always think about. So, is this one a counting principle problem? As long as it's composed of actions and in each action we have a number of choices, then this is a counting principle problem. What do we mean by actions? Look, here we have an individual, and this individual is going to choose 3 books. So he is going to select the first book, take it out of the shelf, and then he is going to choose a second book, take it out of the shelf, and then he is going to choose a third book. So these are called actions. So, and we mainly have 3 actions in this question. The first action is selecting an Arabic book. So here we want to select an Arabic book. The second action is to select an English book. So here we're going to select an English book. And the third action is selecting a book that is written in French. So this is a French book. And now we should investigate how many options or how many choices do we have in each of the actions. Now, the first action, which is the Arabic, how many options do we have there? Okay, if we read the question again, it says that in a library we have a shelf that holds 7 Arabic books. So we have 7 options. So here we simply write 7. When we come to the English book, now how many choices do we have for the English book? We only have 5 English books, so we have 5 choices. And then when we come to the French books, we have 4 choices since we have only 4 books. So the answer to this is going to be the product, the multiplication of the 3 numbers. So 4 times 5 is 20, and 20 times 7, we get 140. So the question is, in how many ways? So this is 140 different ways. And that's it. That's the first question. So this question was a counting principle question because it simply can be divided into a number of actions, and then in each action we have a number of choices, so we simply count the actions and then multiply them by the choices. Okay, let's look at the second question. The second question says the following. In a theater, there are 8 vacant places in a row. Vacant places are empty places, so we have 8 empty places in a certain row. In how many ways can we seat 5 people there? Okay, so there are 8 places and we want to seat 5 people. Let's look at the actions. What are the actions here? The action is seating the people, not the chairs, seating the people. Because I am going to call the first guy, for example, and then I'm going to choose a place for them. And then I'll choose the second one, and then I'm going to choose a place for them. And then the third one, and so on. So I'm going to seat how many people? I'm going to seat 5 people. So I don't have 8 actions. This is maybe an idea that you might have, that we have 8 actions. No, we don't have 8 actions. We have only 5 actions because we want to seat 5 people. So seating the people is the actions. So we have 5 actions. Okay, and then what? And then in this action, we're going to seat the first guy. So we're going to take someone from the 5 and then we will seat him. How many choices do we have now? We have 8 choices because there are 8 vacant places. So it's 8 choices. So I can seat him in any of the 8 chairs. For example, chairs A, B, C, D, E, F, G, H, I can seat him in any of those. Now, when I choose the second person, he will not have 8 choices this time. He will have 7 choices. Why? Because this guy has already sat on a chair. So now there is a chair that is not vacant anymore, and we have only 7 vacant chairs, 7 vacant places. So now we only have 7 empty places, and that's why we have 7 choices. When we call the third guy into the theater, we're going to offer him 6 choices. So he only have to sit in one of 6 places. When we call the fourth guy, he is going to be seated in one of 5 places or 5 options. When we call the last guy, he will only have 4 choices. And now the answer to this is going to be 4 times 5 times 6 times 7 times 8, or what we can say, permutation of 5 actions, and the largest of which is 8. Now this is an important note now. Look, we have solved this problem as a counting principle, but the answer is a permutation, and it's really okay. Permutation is a special case of counting principle. Permutation is only one special case of counting principle. So if you have something in counting principle and it turns out to be permutation, it's fine. If this question is a multiple choice question, you might have this as one of the answers. So we solved it as a counting principle, but we can express the answer as a permutation, and it's totally fine. Let's see the third question. If you have any problem with any question, please send me the number of the question, and I'll try to explain it for you even further. So let's see the third one. In how many ways can we arrange 5 different books on a shelf? 5 different books on a shelf. So I have 5 books, and I have a shelf, and I want to arrange these books on the shelf. Okay, so how many actions am I going to do? Well, I will do five actions. I will put the first book, then the second, then the third, then the fourth, then the fifth. So these are 5 actions. In the first action, I have 5 choices because I can choose any of the books and put it in the first place. And then in the second place, I have 4 options, then 3 options, then 2 options, then 1 option. This answer can be expressed as 5 factorial, or it can be expressed as permutation of 5 actions, and the largest number in these 5 actions is 5. And you might now recall that n permutation n is equal to n factorial. So these 2 answers are basically the same thing. Okay. Let's move on to number 4. In how many 4-digit numbers can we form from the set 1, 3, 5, 7, 9? Okay. So 4-digit numbers. How many actions are these? These are 4 actions. And then how many choices do we have in the first one? 1, 3, 5, 7, 9. There are no conditions. So I have 5 choices. And then 4 choices. And then 3 choices. And then 2 choices. I think the question here is without repetition. So 5, 4, 3, 2. And this answer can be expressed as 5 permutation 4. I forgot to write without repetition. It is supposed to be without repetition. So this is 4 actions starting from 5. We can write the answer either as 5p4, 5 permutation 4, or 5 times 4 times 3 times 2. And please remember that since your exam is a multiple choice exam, you might have this as one of the answers. So you're totally fine there. Let's look at the third one, the fifth one now. Okay, let's see. So 5 teachers and 5 students desire to sit on 10 chairs that are arranged in a straight line, such that the teachers would sit next to each other, and so with the students. So the teachers will sit together and the students will sit together. In how many ways can we do that, or in how many ways can that be performed? It's really important that you think about the question logically before you solve it. And it's important that you try to imagine the question and try to imagine all the possible answers. You have to imagine all the possible answers. It's important that you imagine all the possible answers, because if you do so, you'll get the correct answer. Let me show you how. Now, I have 5 teachers and 5 students, and they want to sit on 10 chairs. So I'm going to seat 10 people. So I have 10 actions. And 10. So I'm going to have 10 actions. 5 teachers and 5 students. And they want to sit on 10 chairs. Okay, I have the 10 chairs now in front of me. These are the 10 chairs. Now, the 5 teachers want to sit next to each other, and the 5 students also want to sit next to each other. So it might be common sense that you say that, okay, so since the teachers want to sit next to each other, so this is a teacher, a teacher, a teacher, a teacher, a teacher, and then I'm going to have a student, a student, a student, a student, a student, and they solve the problem. And then you can say that, okay, so how many options do I have here? Since I have 5 teachers, so I have 5 options. And then I have 4 options, and then 3 options, and then 2, and then 1. And then I'm coming to the students. So I have 5 students first, and then 4, and then 3, and then 2, and then 1. So this is basically the answer. You might be satisfied with this answer, but this is not the full picture. Why? simply because there is another possibility. How is that possible? How can we seat these teachers and these students in a different way? Well, look at this, guys. We can do the following. Instead of starting by seating the teachers first, we can start by seating the students first. And then after I seat the 5 students next to each other, I can seat the 5 teachers next to each other. So this is another scenario. So I can either start by seating the teachers next to each other, so like this, teachers next to each other, and then the students next to each other. Or I can do the opposite, which is seating the students next to each other, and then the teachers next to each other. So I have 2 different possibilities. And actually I can do both, so you have to think about both. You have to think about all the possibilities in which you can solve the problem. This is an important factor of solving any problem. So now I have this scenario, the first scenario, which is seating the 5 teachers first and then the 5 students second. Or I can seat the 5 students first. So 5, 4, 3, 2, 1, and then the 5 teachers together, which is 5, 4, 3, 2, 1. So how does this translate into an answer? Okay, let's see. So the first 5 here is 5 factorial. So this is 5 factorial. Multiplied by the second 5 is also 5 factorial. So multiplied by 5 factorial. Or always translate into addition. So whenever you have or, it means plus. So plus. This 5 is 5 factorial times 5 factorial, the other 5. And, okay, now look at this, guys. Whenever you have x plus x, the answer is 2x, right? Whenever you add something with itself, the answer is, you just multiply it by 2. So I'm adding this with itself. That's an addition. I'm adding 5 factorial times 5 factorial with itself. So the answer would be 2 times 5 factorial times 5 factorial. So this would be the answer. So you can expect one of those in the choices. You can even expect in the choices, you might not find this in the choices, but you can find 2 times 5 permutation 5 times 5 permutation 5, which is possible, which is the same thing as the previous one, because n permutation n is n factorial. You can also expect 2 factorial times 5 factorial times 5 factorial. This is also possible, because 2 factorial is 2. 2 is 2 factorial. It's the same thing. Now I'm giving you these different choices because maybe you will not find this in the answers. Your exam is a multiple choice question, so you might not find this choice. So you might find this choice, which is the same. Or you might find this choice, which is also the same. Or it can be even 2 permutation 2 times 5 permutation 5 times another 5 permutation 5. These are all different answers, and they're all the same value. So they're all possible. You can have either of the 4, okay? So all of these answers are correct, and if you find any of them, then it's correct. We'll see another question like this with more than one scenario, inshallah, later on within the same class. Let's continue on. Let's carry on. So let's look at this question, question number 6. So the question says the following. I hope this is clear. Yeah, so in how many ways can we fill 2 empty places on a library shelf if there were 4 books to choose from? Again, in how many ways can we fill 2 empty places? So how many actions do I have here? I simply have 2 actions. So these are 2 actions. I want to fill 2 empty places. In a library, on a library shelf, if there were 4 books to choose from, so how many choices do I have here? I have 4 books to choose from, so I have 4 choices. And how many choices do I have in the second one? Well, of course I have 3 because I'm going to place a book here. So the answer is 4 times 3, or it can be written as 4 permutation 2. Why 2? Because there are only 2 actions. And this is a straightforward question. Another one, 7. In how many ways can we arrange 2 letters that were chosen from the set A, B, C, D, E? Okay, so we want to arrange 2 letters. The question does not say without repetition. So if it doesn't say so, you assume that repetition is allowed. Whenever it doesn't say without repetition, you assume that repetition is allowed. In the previous question, I added without repetition because I forgot it from the question. But in this question, they don't say whether they want it with repetition or without repetition. So as long as they say only 2 letters, so we assume that repetition is allowed. So 2 actions, 2 letters, 2 actions. How many options do I have? 1, 2, 3, 4, 5. Would I have 5 options? And then I have also 5 options, assuming that I can repeat. So repetition is allowed. So the answer can be also written as 5 squared. But we cannot write this answer as a permutation, and we cannot write it as a factorial. It can be written as a power 5 square. Notice something here. If they say, in how many ways can we arrange 2 different letters? If they add the word different, so they say different letters, so repetition is not allowed because it's different. But as long as they did not specify anything, so we assume that repetition is allowed. Let's carry on to question number 8. Okay, question number 8 says the following. Among 30 students, in how many ways can we form a committee? A committee is like a group of people, of students. So we want to form a group. We want to make a group of students consisting of a chief. So we want this group to have a chief, to have an assistant, to have a secretary, and to have a treasurer. Treasurer is someone who's responsible for money collection, things like that. So we have 4 people now. We have a chief, we have an assistant, we have a secretary, and we have a treasurer. And we want to know in how many ways can we select these 4 students. Now this is an important question. This is a question that means a lot in your understanding to the lesson. We said in permutation that we select people, and after we select people, we arrange them. And in combinations, we only select people. We don't care about their arrangement. Now, there are 30 students. Imagine that your class is 30 students, okay? Are you going to select only 4 people and then not arrange them? Or are you going to arrange them after you select them? Now, for example, imagine that your class is 30 students. And I have selected students A, B, C, and D. These are 4 different students. I have selected them. Will I leave them after I select them? Or is it important to say who is going to be the chief, and who is going to be the assistant, and who is going to be the secretary, and who is going to be the treasurer? I mean, after I select A, B, C, D, I can put A as the chief, and B as the assistant, and then C, and then D. Or I can put B as the chief, and A as the assistant, and then C and D. Or I can put C as the chief, or I can put D as a chief. So I'm not only selecting people, I am selecting people and then I'm arranging them. Why do I want to arrange them? Because they have different responsibilities. Actually, whenever there are different responsibilities, then it is permutation. Why is it permutation? Because I am selecting, and then after that, I care about their arrangement. So this is going to be a permutation problem. So always bear in mind that whenever we select people and those people have the same responsibility. If they have the same responsibility, then I don't care about their arrangement. If the 4 are going to be in the group, and that's it, then it really doesn't matter who I select first, or the second, or the third, or the fourth. They're going to have the same responsibility after all. But if they have different responsibilities, then after I select them, I need to arrange them. I need to put each one of them in a place. So this is arrangement. So as long as we have arrangement, we have permutation. And how do we solve a permutation problem? This is easy. So there are 30 people, and we want to select and arrange 4. Chief, assistant, secretary, and treasurer. So the answer is going to be 30 permutation 4, and that's it. That's the answer. The answer is 30 permutation 4 because there are 30 students. There are 30 students, and we want to select and then arrange 4 students. Select and arrange them. I hope that this point is clear because this point is really important in the lesson. Let's look at number 9. The question says, how many one-to-one mappings, they call them injective mappings, can we form from the set A, 1, 2, 3, into B, which is A, B, C, D, E? Okay, I think we have explained the lesson, a question like this before in the class. I hope that you still remember it. Mapping is when we have 2 sets. This is A, and this is B. And in A, we have 1, 2, 3. In B, you have A, B, C, D, and E. And in mapping, we draw arrows from here to here. The most important thing is that each one of these numbers should have an arrow next to it. So we have to draw an arrow from each one of them. And it should be only one arrow. When we say it's one-to-one mapping, it means the following. It means that if you make an arrow from 1 to A, you cannot draw an arrow from 2 to A because it's going to be 2 to 1. He says 1 to 1. So each one here should have one here that is unique for him. So this element should have an element from here that is unique for it. So 1 is paired with A. 2 cannot be paired with A. This is one-to-one mapping. If I don't say this word, and I think the question that we solved in the class was without this word. So we said how many mappings directly. How many mappings? In mappings, we can do this. We can draw an arrow to the same number, no problem. But if they say one-to-one mapping, it means that we cannot point the arrow to the same number twice. We have to select a different number, like this, for example. This is a one-to-one mapping. How many actions am I going to do? Well, I'm going to draw a first arrow, a second arrow, and a third arrow. So I have 3 actions. For the first arrow, from 1, how many options do I have? I have 5 options. From the second, how many options do I have? I don't have 5 options. I have 4 options. Why? Because I can't point the arrow to the same number again. So if I choose a number for 1, I cannot choose it for 2 anymore. So I have 4 options. And how many options do I have for 3? I have 3 options. So the answer to this is going to be 4 times 5 times 3, which is 60, yes, but I prefer that you write the answer as 5 permutation, 3 actions. Because this is what you might have in the choices in the ministry. Okay, so we carry on. Let's investigate some more questions. I have tried to make the questions mixed, some from permutation, some from counting principle, and soon you will see some from combination, because I want you to get a sense of the differences between each one of them. So let's see. Here in this question, they say, in how many ways can we arrange? Okay, so they have solved it for us. They said arrange. If they say arrange, then they mean permutation. Sure, arrange is permutation. So, in how many ways can we arrange 8 people in the following cases? On a straight line and around a circular table. Okay. Now this one is an important question as well. Let's see. We want to arrange 8 people on a straight line. So we have 8 places for them. So if you have 8 places for those 8 people, it's going to be 8. The answer is going to be 8 people. And you want to arrange them in 8 places. So it's 8 permutation 8. You're going to do a counting principle. Draw 8 places. You have 8 choices, 7 choices, 6, 5, 4, 3, 2, 1. So the answer is also can be written as 8 factorial. Okay. But however, when it comes to a circular table, the matter is a little bit different. And to explain this, let's put this aside a little bit and let's solve an easier problem. Let's say that we want to arrange 3 people, okay? Or let's make it 4 people. Let's see. So, just a second, please. Okay, so let's say that we have 4 people and we want to arrange them in 4 places. 4 people and we want to arrange them in 4 places. So let's say that we have these 4 people. I have person A, B, C, and D. These are 4 different people. And we want to arrange them in 4 places. And these places are in a straight line. So we want to arrange them on a straight line. Please pay attention to the following. How many arrangements can I do? Well, I have 4 actions. I have 4 choices, 3 choices, 2 choices, 1 choice. So the answer is going to be 4 factorial, and 4 factorial is 24. Say that I want to see these arrangements. Okay, let's show them to you. I can put A at the beginning in 6 of these choices. And then put B after him in 3 of these. Put B after him in 2 of them. Or put C or put D. And then I can put either C or D here, either B or D here, either B or C. And the opposite, which is A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, A, D, B, C, and A, D, C, B. So these now are 6 different arrangements. 1, 2, 3, 4, 5, 6. 6 different arrangements. And these 6 different arrangements are the first arrangements we can make out of the 24, starting with A. I have other 6 different arrangements, which are starting with B, and then I have A, or C, or D. And then I have here either C or D. Here either A or D. Here either A or C. And then I can have here BACD, BADC, BCAD, BCDA, BDAC, and BDCA. Okay, these are 6 different arrangements that I can make starting with B. And I can make 6 different arrangements starting with C. Notice that each one of these arrangements is unique. And I mean by unique that you cannot repeat it again. It's not repeated. So these are 6 different unique arrangements. Each one of them. And these are all the possibilities. You can't have more possibilities than these. These are 6 arrangements that's starting with C, and you can do 6 arrangements that are starting with D. So D, 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 and D. Then A, B, C, and then here we can have either C or B, B or C, either A or C, C or A, either A or B, B or A. You can't find two arrangements out of these 24 that is repeated. They're all unique, they're all different. And you can't have more than these arrangements. These are all the possible arrangements of 4 people on a straight line. They either can stand like this, or like that, or like that, or like that, or like that, like 24. 24 different arrangements. How does this become different if you try to seat them around a circle? Now look at this, guys. If we try to seat them around a circle, this is a circle. If you try to seat them around the circle, you will have A here, then B, then C, then D. You will have this arrangement. This is one arrangement, A, B, C, D. It looks like this one, A, B, C, D. Or you can have A, then B, then D, then C. This is the second arrangement, A, B, D, C. Or you can have A, and then C, and then B, and then D. This is the third arrangement. Or you can have A, C, D, B, A, C, D, B. That's the fourth arrangement. Or you can have A, D, B, C, A, D, B, C. That's the fifth arrangement. Or you can have A, D, C, B. That's the sixth arrangement, right? And then you'll argue that we will move on to the second possibility, which is let's show you here, which is B, A, C, D, right? B, A, C, D. This one. Let's do that. So B, A, C, D. This is a new arrangement, right? Well, actually, if you look carefully, this is not a new arrangement. It's a circle. You can look at the circle from any place. And if you pay close attention, this is the same as this one. This one and this one are the same. This is A, and then C sitting here, and then D sitting here, this is D, and this is B. So this arrangement is not unique. It's repeated. It has been done before. And we cannot say that this is a new one. So we simply don't accept it. We don't want this arrangement. This is not a unique arrangement. Okay, so let's try another arrangement. So the first arrangement here in the second row, this arrangement failed to be unique. It's not unique. Yes, on a straight line it was unique. But around the circle, no. We rotated the circle and we got the same thing. Let's try another one. Let's try this one. So B, A, and then D, and then C. I'm trying this one, B, A, D, C. Okay. Is it unique? Let's rotate it again. Let's see. I have A, then D, then C, then B. It's the same arrangement. This arrangement and this one are the same. So we simply reject this one as well. And actually, if you try, you'll find that all of these are going to be rejected. All of them. They're not going to be unique. They're going to be these ones rotated. And all of these are going to be rejected. Why? Because they're going to be this one rotated. And all of these are going to be rejected as well. You will not accept any of them. Let's try one of them, just one of these, just to make sure. Let's try CBAD. Let's try this one. CBAD. So CBAD. Let's rotate it now. It's ADCB. 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 A is here, D is here, C is here, and B is here. This one is the same as this one. So it's rejected. Okay, so what do we get from here? So the number of arrangements is not 24 anymore. It is actually 6. 6 possible arrangements only. If it's around the circle, it's only 6. If it's a straight line, it's 24. If it's a straight line, it's 24. If it's around the circle, it's only 6. Why 6? Because we need to make a beginning for the circle. If you put A here at the beginning, if you fix the place of A, then you have 6 different possibilities to change B and C and D. If you start changing B from here, if you don't put A here, if you put B, then you're not going to have unique answers. So whenever you have a circle, and actually this does not only apply to circles, it applies to any closed shape. Whenever you have a closed shape, whether it's a circle, like a circular table, or a square, whatever, any closed shape, whenever you have a closed shape, the number of arrangements drops by 1. What do I mean by that? It means you're not going to have n factorial. Instead, you will have n minus 1 factorial. Why minus 1? This one is the one that you need to fix. Notice in the previous drawing I made for you, we have fixed the place of A. So A was fixed. It was fixed on the top of the table. Once we changed A, we did not have new answers. We had the same answers. So it's basically like, I will put A at the beginning of the table. I will say that this is the beginning of the table. And then I will start arranging B and C and D. So I'm not going to arrange 4 people in that example. Instead, I arranged only 3 people. It's the same thing here. How many people I have? 8. I am going to put one of them in a fixed place. I'm not going to change it. And then I am going to start changing the places of n minus 1 people, 7 people. So the answer to part B is not going to be n factorial. It's not going to be 8 factorial like this one. It's going to be 8 minus 1 factorial. And the answer to that is going to be 7 factorial. And you can take this as a note, which is arrangements around any closed shape is n minus 1 factorial. Whatever the closed shape was. You have a circle, it's n minus 1. You have a square closed, you have n minus 1. Whatever the closed shape is, as long as it's symmetrical, we say sometimes, but you don't take other things other than symmetrical. So whatever the closed shape is, you just put n minus 1. Okay, so this is question 10. Question 11. In how many ways can we compose a flag consisting of 4 colors chosen from 9 available colors? Okay, how many colors do you have? 9 colors. You want to choose 4 colors. Do you want to choose them and throw them? No, you want to choose them and arrange them. Usually in colors, you don't have repeated colors. In flags, I'm sorry. Usually in flags, you don't have repeated colors. So we will say that here repetition is not allowed. So how many colors do I want to choose? I want to choose 4 out of 9. And do I want to arrange them? Yes, but yes, we want to arrange them. because it's a flag, we have to arrange these colors. If we put the red and then the white and then the black, that is Yemen. If it's a different order, it's a different country. So we have to arrange them. So it's an arrangement. So it's a permutation. Of how many people? Of how many colors? 9 colors. And how many do we want to select from them? It's 4. Or you can say it is 4 actions, 4 colors. Here we have 9 choices and then 8 choices. Repetition is not allowed. And then 7 choices and then 6 choices. Both answers suffice. They're both good. All right. So let's continue. This question. In how many ways can we seat 4 students and 4 teachers on 8 chairs on a straight line, such that each student will sit next to a teacher alternatively? This question looks like the previous question. Let's draw it. I have 8 chairs. I have 4 students and 4 teachers. And I want to seat each student next to a teacher. So I can seat a student here and then teacher. Student, teacher. Student, teacher, student, teacher. But I must ask myself, is there another scenario possible? Is this the only way I can do it? Or maybe there is another way. Well, actually here there is another way, which is, or, what is the other way? Yes, we can seat the teacher first, and then the student. So it's teacher, then student, teacher, student, teacher, student, teacher, student. So I can start with the student or I can start with the teacher from the left. All right. Do I have a third scenario? No, we don't. It's either you put the teacher, then the student, or the student, then the teacher. So let's see. I have 4 students, and then the number drops to 3 students, and then 2 students, and then 1 student. That's 4 factorial. And I have 4 teachers, and then 3 teachers, and then 2 teachers, and then 1 teacher. That's another 4 factorial. So the answer is 4 factorial times 4 factorial. Or plus, same thing here. 4, 3, 2, 1, 4, 3, 2, 1. So 4 factorial times 4 factorial. So the answer is 2 times 4 factorial times 4 factorial. And I would encourage you to try to get some other answers, some other possible ways to write this answer, like we did in the previous example. I'm not going to do it. I'll leave it for you. Question 13. In how many ways can we select 5 questions to answer in a mathematics test that consists of 6 questions? So this test has 6 questions, okay? And the question is, in how many ways can we select 5 questions to answer? And now let's ask you a question. Is in exams, is the order important? Am I going to punish you if you solve question 3 before you solve question 1? I think no. No teacher is going to do so. So in exams, the order is not important. You select the questions, but is it important after you select them to order them? No. So in this case, it's not a permutation, because in permutation, arrangement is important. Arrangement is important. And as long as in this question, arrangement is not important, so in this case, this is a combination. Yes. So how do we do this? We say the answer is a combination. How many questions do we have? We have 6 questions, and we want to select 5 questions out of them. So this is the answer. Or we can write this answer as 6 combination 1. Why? Because of the reduction rule. 6, 5 is the same as 6, 1. 6 minus 5 is 1. This is the reduction rule. Please watch these videos in order so that you understand what am I saying. We can write combination 6, 1 as 6, 5 as 6, 1 because of the reduction rule, and 6, 1 is 6. So the answer is 6. So in how many ways can we select 5 questions to answer In a math test that consists of 6 questions, it is 6 ways. And that's it. So this question was a combination question. Why? Because it's only selection and there is no arrangement. So whenever there is no arrangement, it's a combination question. And please, sometimes they will tell you arrange or select, but sometimes they won't. You have to figure it out. You have to make sense of it. So you have to study the logic of the problem. Okay, since this lesson is getting long, I think I am going to do this page, and then I'm going to leave the rest of the questions for the next class, inshallah. So I might be dropping a video on Thursday, inshallah, which is the day after tomorrow. I'm sorry. I'm going to drop another video. So we solve the other questions from 18 to 30. You can think of this as an extra class. Let's see. Here. In how many ways can we select 4 books at least out of 8 books? At least is a key word here. At least is an important word. Why? First of all, there is also the word select. So we want to select 4 books, but we don't want to arrange them. Just select them. So is this a combination or a permutation? It is a combination. Because you only want to select, you don't want to arrange. So it's a combination of 4 books out of 8 books. But they say at least. What do we mean by that? It means we want to select. So we want to select 4 out of 8, right? Or select 5 out of 8, because they say 4 at least. The least thing is 4. So 4 or 5 or 6 out of 8 or 7 out of 8 or 8 out of 8 or 8 out of 8. How do we express that? Okay, let's see. So it's a combination of 4 out of 8. Select 4 out of 8. Or means plus. Select 5 out of 8. Or select 6 out of 8. Or select 7 out of 8, or select 8 out of 8. So these are all the possibilities. 4 at least. 4 at least. 4 at least out of 8, or 5, or 6, or 7, or 8. And remember that or translates into addition. We can simplify this a little bit. Maybe we can say that this is according to Al-Kirchi's relation. If we have the same n and r are different and there's plus between them, I can add 1 to n and select the bigger r. Plus, same thing here. I can add 1 to n and select the bigger r. Or combination 8, 8 is 1. Please, you have to master the rules well before you attempt to understand these questions. You have to know the rules very well. These are Al-Kirchi's relation. These two are Al-Kirchi's relation. These two are Al-Kirchi's relation. I can do that. And 8, 8 is 1. Combination 9, 5 is the same as combination 9, 4, right? According to the reduction formula. And this is the same as combination 9 minus 7 is 2, plus 1. I can solve this and add it with 1 and see how much is the answer. I'll just leave that for you. You know how to open a combination, how to evaluate it. So evaluate 9, 4, change it to permutation over 4 factorial. And the same thing here, 9 permutation 2 over 2 factorial. And solve them and add the answer to 1. Let's look at the last question we do today, which is 15. It says, in how many ways can we select 3 different books, at most out of 8 books. At most, huh? Here at least, here at most. And we want to select, only select. So we want to select 3 out of 8 at most, or 2 out of 8. Because at most, or 1 out of 8. Or 0 out of 8. 0 is also a choice. So it's a combination 8, 3 plus combination 8, 2 plus combination 8, 1 plus combination 8, 0. Using Al-Kirchi's relation, these two can be combination 9, 3, and these two can be combination 9, 1. Combination 9, 1 is 9. Combination 9, 3, I'll solve this one for you. So it's 9 permutation 3 over 3 factorial plus combination 9, 1 is 9, which is equal to 9 times 8 times 7 over 3 times 2 times 1 plus 9. We can cancel 3 with 9, we get 3. 2 with 8, we get 4. 3 times 4 is 12. 12 times 7 is 84. So it's 84 plus 9, which is 93. You can have this answer in the choices. You can have this answer in the choices. You can have this answer in the choices, or you can have the whole string in the choices. They're all the same thing. So I'll leave you with this. I'm not going to give you homework for now. I just want you to study this well. I know the class today had some ambiguity. There are some ideas that are new to you. So if you feel it's strange, repeat it again. And try to notice the differences for yourself. Try to notice the differences between the questions yourself. And tomorrow, inshallah, I'll be dropping another video in which I'm going to start solving question 16 up to question 30. So I'll see you tomorrow, inshallah. Stay safe and study well, and I hope I see you soon.